Oh, hey, here we go. So this is a question solving a solid of revolution, okay, for this shape here, okay. We've got the secant function and then the one line y equals 1 here. And so I'm going to break this into two functions, sort of the upper function minus the lower function, each of them squared. The difference between those is going to be the radius of my circle or of revolution, right? So, basically if I use my secant function as my upper function, so basically like from here to here, okay, and then I take away this function, so that was this line right there, and I take away sort of, I guess I'll use a blue, this line right here, okay, then it's going to leave me this section right there, which will then be rotated around in a donut or washer type situation, okay, and thus give me the solid of revolution, okay. And what I'm going to end up doing here is, instead of doing it from -1 to 1, since it's symmetrical, I'm actually just going to do it from 1 to 0. So from 1 to 0, and I'll multiply it by 2. So that's why this 2 happens to be here. All right. Otherwise, you could do it from -1 to 1, and you could just leave a single pi right there. All right. But I'm just going to double my overall volume. Okay. So now if I just populate my formula with the given functions, secant and y equals 1, notice that the integral of secant squared is tangent, and the integral of 1, because 1 squared is just 1, is going to be x. And I'm integrating that from 0 to 1. And so what I'll do is I'll evaluate that at 1. So tangent 1 minus 1 minus the whole thing, again, evaluated at 0. So tangent 0 minus 0. But remember, tangent 0 is 0, and so that's pretty okay. This all cancels, basically leaving me 2 pi tan 1 minus 1. All right. And that's going to be our volume there. All right.